I will introduce to you today this Shack Hartmann lift technology, which is a new feature in the world of Shack Hartmann. So let me share my screen. This is lift technology. That means that this lift meaning is linearized focal plane technique, which is a new feature in the domain of Shack Hartmann metrology. We are proud today to have this new feature coming out from earlier this year. We have already some customers working with that, and they are really happy to be able to have a more resolution using our Shack Hartmann sensors. This technology is now available from April on our website. This is the HASO LIFT 272 or the HASO LIFT 680, which means the resolution is higher than the usual Shack Hartmann we propose. So you can have access to all the details on this product on our website, or you can also contact me using the contact webmail using contact@imaginoptic-.com. Sorry. Let's see how it works. So this is the usual wavefront measurement, which means that we are in the normal case with this Shack Hartmann techniques, we are just imaging the centroid of the spot on the camera. So this means that usually it's giving some slope, and the Shack Hartmann per microlenses is giving a slope, a normal slope. Now with this technology, we will have a study on the shape of the PSF that we can analyze, not only the position of the centroid, but also the shape of the Shack Hartmann microlens image. So having a specific hardware on a very huge software, new software algorithm, we can retrieve by the phase, we can retrieve the resolution of this shape on the camera sensor. So it's giving us more resolution. In fact, instead of having a single slope, we have now a new high resolution shape of the Shack Hartmann wavefront we analyze. Then the sensor is in the normal way of a Shack Hartmann. The normal sensor is not, the resolution is not as well as the lift one, which is in red there, and the resolution is enhancement is a factor of 4 in each direction. That meaning the improvement is a factor of 16. So you can see on this graph that the normal Shack Hartmann resolution is going down after twice Shannon frequency. And then if you are using the algorithm we have on the hardware we have announced for the lift system, we can have also a very, very good resolution on higher frequencies on the Shack Hartmann wavefront we have to measure. What is how can we propose to study this? We have a good way to show you how physically this is very good enhancement in the Shack Hartmann system. Let's send to a Shack Hartmann a phase hologram through an SLM and send it to a normal Shack Hartmann sensor. It will give you this kind of resolution. This is not as good as the white original image. And now if we are sending the same hologram through an SLM to the Shack Hartmann using the lift technology, we can have this resolution. And here, as I said at the beginning, we have two different HASO LIFT. This one is the 272 resolution, meaning that we have 272 by 200 fast points on the sensor, given by the algorithm of the lift. Now we have the second one, which is the 680 system. I'm now sending the same hologram through an SLM to the Shack Hartmann. We have on the sensor, which is a higher number of microlens on the sensor, we can have already a good shape, a good resolution on the spatial resolution on the wavefront we measure. And if we are going to a lift algorithm, we can have a very, very low details and very, very good retrieval of this original image from this baboon. That's the lift technology. Now let's go to the application we have in this high resolution. This is really a new product, and we released this product in April this year, and we are ready to send to many customers if they need now to have higher resolution, meaning that we are very close to what can do an interferometer. We have a capacity for application for freeform optics, for metasurface measurements, diffractive optics, phase shift, and all the middle life on special frequency characterization. As I said, the high frequency are now achievable on the Shack Hartmann system with this higher resolution. And also for measuring laser impact on some mirror or test mirrors on quantitative phase imaging as well. Then this new Shack Hartmann technology is also available with our AirFlex system. That means that we have a coaxial laser source that can give you the perfect tool to have some lenses measurements, filter measurements, all kind of optical that you can put in a way between a mirror for a single pass or directly for a mirror measurement about the high quality mirrors, of course, because of the high frequency capability from measurement. Our Shack Hartmann technology against the interferometer has a very insensitive to vibration. That's a good point. Now we have high spatial resolution and use dynamics, because the Shack Hartmann using lift doesn't lose the dynamic range they have in the normal Shack Hartmann system. That is already also an advantage against the interferometers. And now the accuracy is the same, lambda over 100 RMS, which is a very good one also. And the Shack Hartmann also technology is achromatic between 400 and 800 nanometers. So that means that you can use different wavelengths as a measurement source. And that's also a better advantage against the interferometer technology. The next image, so you can retrieve on our website all the video regarding this new feature of lifted technology. We have different videos showing you what will be the whole use of this Shack Hartmann, how easy it's friendly use and easy to put in the front of a system to have a very quick setup for an optical metrology of any kind. So if you have some question, I have also Guillaume Dovillers on the chat room here. You can chat with him directly. And also, if you have some question later, you can retrieve the guy. Guillaume will be very, very pleased to welcome you on the networking room for the imaging, sensing, and sensors. So you can retrieve Guillaume for the next hour in this room. ask him directly in live some questions. Then it's time for question. If you are on the chat, please go ahead with your question.